Hello students, welcome to another amazing lecture time with Mr. Moses. So today we will be looking at the law of combination of resistance in a circuit. There are two major ways we can combine resistance in a circuit. And what is resistors in a circuit? Resistors are electrical components that help to resist the flow of current flowing through a circuit. In a circuit analysis, there are basically two ways we can combine resistors in a circuit. The first one is resistors in series. So we can combine resistors in series, and the other one is we can combine resistors in parallel. So in today's practical, we'll be using experimental procedures to be able to verify the law of combination of resistance in series and also to verify the law of resistance in parallel. Then after that, we will be able to do a graphical analysis that will show us if we combine resistors in series and if we combine resistors in parallel, what is going to be our combined resistance, or what we also known as effective resistance. So in this video, I will be showing us the practical procedure for us to be able to actualize this aim. So please sit tight and follow step-by-step process, and after this video you will be able to use practical procedures to be able to find the combined resistance of resistors in series and also resistors in parallel. So next I will be showing us the simple apparatus that is needed for us to carry out this procedure. So to be able to find the combined resistance, the following are the set of apparatus that we need. The first, we need two known resistance. In this practical, we are going to be using two 1 ohm standard resistor. This is one and this is the second one. We are going to be using a variable resistor, which is our rheostat here. We are also going to be using a key. The key is going to help us switch on and switch off. We are going to be using a key. It's going to help us switch on and switch off the circuit. Then we are also going to be making use of our ammeter, and we are also going to be making use of our voltmeter. The ammeter is to help us indicate the amount of current flowing through the circuit, and the voltmeter is to help us indicate the amount of voltage across the resistors. So there are also two ways in doing this. Is either you can use a DC power supply for it, which is also advisable if you have one, and if you don't have one, you can also use this kind of battery for your practical process. So I will be showing us how to connect them together. So with the experimental setup, we connect the negative terminal here. We connect one to the negative terminal, and also we connect from the positive terminal here. Okay. Then we connect from the positive terminal to the key, to one end of the key. Okay. Then after connecting from one end of the positive terminal, connect from one end of the positive terminal to one end of the key, then the next thing we do is we connect from the other, we remove the key, then the other from the other end of the terminal of the key, we connect a wire straight to our variable resistor here, straight to our variable resistor here. Then there are 2 points on the variable resistor. There are 2 points on the variable resistor. Then we connect another wire from the other end, this end here of the variable resistor, this one here. You're losing this top part here, then you tie the wire to this other end, then you knot it back, then you connect this, you connect it to the 3 arms to this other end, to the positive terminal of the ammeter. Then you connect from this end to the positive terminal of the ammeter. Then the current will move out of the negative terminal of the ammeter. Then the black knob, you lose the black knob, and you tie it back. Then you connect it to one end of the first 1 ohm resistor. Then I lose this side, and then I tie this here, then I screw it back again, so that it is tight. Then I put it down. So since we have been able to connect the first 1 ohm resistor to the ammeter, then we connect it end to end. This is how we do the series connection. We connect it end to end, from one end here, just as you can see, to the other end of this 1 ohm resistor. So you can see I'm making the connections here in series. This is the series connection that we are talking about. Okay, both of them are together in series. Okay, I made a connection from this to this. Then the next thing is I'm going to connect to our negative terminal. I'm going to connect straight to our negative terminal. Then from here, I'm going to have one out to the negative terminal. From here, I'm going to take it straight to the negative terminal here. Let me take this off first. Well, then I'll make this connection. Straight to the negative terminal. Straight to the negative terminal. So by doing this, we have been able to make our connections from the supply to the key, then from the key to the rheostat, then from our rheostat, then we connected it in series to our ammeter. Then from the ammeter, we made a connection in series to our 211 ohms resistors. So this is our standard resistor. Then from there, we ensured we make a straight connection back into the negative terminal. But one thing that we have not been able to do, we have not been able to connect the voltmeter in parallel. So to be able to do that, we connect the voltmeter in parallel. How do we do that? So I'm going to use that of the 5 volts. So connect this to the 5 to this terminal, the red. Okay, then this part here. Okay, so take the negative part to this side, to the negative terminal here. Show it meets at the negative terminal. One of the reasons why I'm doing it is so that the deflection, if you have a wrong connection, you will see that your voltmeter will be deflecting the other way. The same thing with your ammeter too. If your ammeter is not properly connected, you will see that there's going to be a wrong deflection if the polarities are not actually in the right place. You will see if the polarities are not in the right place, you will see that your ammeters will the ammeter will be deflected in the other side. Instead of it moving deflecting towards the right, it will deflect towards the left. So this, by me doing this, I've been able to succeed. So guys, we have been able to connect our voltmeter in parallel, and we have been able to connect the circuit following this circuit diagram that we can see now. So the next thing we are going to do is we are going to look at the corresponding current flowing through the circuit, and also the corresponding voltage as being read by the ammeter and also the voltmeter. So the next thing I'm going to do, the circuit, we have that the voltage supply is already on, but we have not been able to put our key, so there's not going to be any deflection in the circuit. So now this is my key. I'm going to put my key there. Okay, now by putting my key, you can see now that there's a little deflection in the ammeter and there's a little deflection in the voltmeter. So as a beginner, at first I'm going to record the initial reading of the ammeter and the voltmeter as my number one. Now, so the next thing I'm going to do is, using my variable resistor, I'm going to slide the variable resistor in to 3 different points. So I'm going to slide it gently and observe the variation. So I'm going to make my first slide at this point here. Okay, as you can see now, the voltage shifted. So the voltage shifted here. In my ammeter, I have the ammeter reading to be 0.2, and at 0.20 my voltmeter is reading 0.40. So the next thing I'm going to do is I'm going to make another slide again. Let me slide it forward again. At another slide, I'm having my ammeter reading to be, let me make another slide again and see. I'm sliding it from left to the right. So here at this point here, okay, my ammeter is at 0.4, while my voltmeter is at 0.9. My voltmeter is at 0.9, 0.4, 0.9. Then I'm going to take another the third slide again from the beginning again. Let me take it to another point again. Okay, at the third slide, okay, let me make the third slide. Okay, the third slide, I'm having my ammeter is giving me 0.2, while my, okay, I think I've had 0.2 before, so let me see another slide. Okay, at 0.3 my ammeter is giving me 0.3, while my voltmeter is giving me 0.6. Then I'm going to take the last slide. Let me take it again from, and I take my last slide. I think my ammeter is giving me I think at 0.5 for my ammeter, the voltmeter is giving me 1.1. So with that, I'm going to take off my key and make a plot. So with that, I will take my readings. Just as you can see, I'm taking my readings. Then I'm going to insert them into my table of value. Then from there, I'm going to carry out my readings to find the combined resistance of the 2 1 ohms resistor. Table. So guys, having followed the experimental process, this is our table of value. So as you can see, we have our current, we have our voltage, and we have the voltage all over the current. So where we have 0.1 for the ammeter reading, this is the successive reading 0.15, and we did 0.15 divided by 0.1, it gave us 1.5, and similarly for all of these. Then after this, the next thing we are going to do is to calculate the average voltage all over current. That means we are going to say 1.5 plus 2.0 plus 2.25 plus 0, okay, plus 2.0. This is 2.0, 2.0. Oh, sorry, this is 2.0. Yes, 2.0. This is 2.0 plus 2.0 all over 1, 2, 3, 4, 5. So we divide everything by 5. Divided by 5. So if we do that, 9.75 divided by 5, this will give us 1.95, approximately 9.15. So our voltage, the average voltage all over current, will give us 1.95 ohms, which is approximately 2 ohms. Now, how do we calculate our resistors in series? The effective resistance for resistors in series, REFF, is equals to R1 plus R2 plus dot 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 plus Rn. But since we are talking about only 2 resistors, our effective resistance is going to be R1 plus R2. But remember, we used 1 ohms resistor. That means our R1 is equals to our R2, which is equals to 1 ohms resistor. So with respect to that, our effective resistance is going to be 1 ohms plus 1 ohms, which is equals to 2 ohms. So you can see that during the experiment, we have an approximate value of 1.95 ohms, and for the effective resistance using our theoretical calculation, we have 2 ohms. So you see it, approximate value 2 ohms and 2 ohms. To this, we have been able to verify connection of resistors in series using this experimental procedure. So I believe at this point I have been able to show us how to calculate resistors in series. So ensure you like, you follow, and also comment if you're having any issue. And please don't forget to click the subscribe button so that our next video for resistors in parallel, you'll be able to see them. So this is also the graphical analysis when we use an Excel to plot it. And if you also have your graph sheet, you can also use your graph sheet to plot, and you will get similar values with an approximate slope to be equal to 2 ohms. And your slope, the significance of your slope is the effective resistance.